All right, this video is a second question in 11.6 where we're going to do optimization, find that max or min. For this one, it is definitely business oriented. So a company manufactures X cell phones per week, and then we have a formula for price and cost, and these are price, demand, price, cost, demand. What price will give the maximum weekly revenue? All right, well, what's revenue? You should think of price times X, right? So just think about this. Your revenue of X is going to equal your price times X, how many things you sell. That's your revenue. So X represents how many items I sold times my price. That's our revenue. So we're going to maximize weekly revenue, but we know that we have a price formula for this. So revenue will equal 700 minus 0.2x times X. Now we want to maximize this function, so we're going to multiply it out so we could use a quick derivative. Now let's do the derivative of that. So the derivative is going to be 700 minus 0.4x. 700 minus 0.4x. So now where's our critical value for this? So minus your 700 over, divide, and I get 1,750. So if I sell 1,750, I have now maximized my revenue. So you could put this number back into either of these functions up here to find the price, the cost, and back into our original revenue to find the max revenue. So you might find this answer and have to plug it back into some of those other functions depending on the kind of questions you're asked. Okay, so for this company for maximum revenue, the company would produce 1,750 phones each week at a price of $750 for a maximum revenue of $612,500. So I found those numbers by putting them back into some of those functions. I could be asked something different from this same problem. I could be asked, what price should the company charge for the phones to maximize weekly profit? So what price should the company charge to maximize the weekly profit? What is profit? Revenue, right? All that money I'm bringing in minus cost. So now we're going to need that revenue function we wrote in the one before, and then we're going to need our cost function. So we would have 700x minus 0.2x squared minus 30, was it 30,000? Yeah. Plus 110x. I know when I move my head you can't hear me, that's why I keep coming back to the middle. But I have a suspension, every time I use a microphone, I can't even use the videos because it's like this weird noise and I don't know, it does crazy stuff. So I think there's something wrong. Okay, so what are we going to do from here? We're going to simplify this profit so that we can do our derivative. Okay, so we have this is our x squared, so negative 0.2 x squared. We wrote that down. 700x minus 110x would give me a positive 590x. And then we just have the 30,000, the negative 30,000. And you could have distributed the negatives to do easier, up to you. Now, derivative. That's going to give us negative 0.4x plus 590. So negative 0.4x plus 590 is our derivative. So we set this equal to 0, right? And that's going to give us our critical value. So I subtract the 590 over. Divide by the negative 0.4, and I get 1,475 phones. It's not the same answer. So to maximize profit, I need to sell 1,475 phones each week. Again, I could go back and plug this value in. Well, I didn't double check that this is an absolute max or min. But honestly, if we take the second derivative of the profit, what would we get? Negative 0.4. So we know that it has to be all concave down again. And so we know absolute max. I know I keep forgetting to skip that a little, but it is really important. Okay, so then again, what can we get from this? Well, we can plug this in, and that would tell us, well, maybe that the company should produce 1,475 phones each week at a price of $405. So I put this X back into the price function from the very beginning. For a maximum profit of, I put this into the profit function, original function, and I got $405,125. So you might have to take this number again and plug it back in and answer some of the questions. All right, so hopefully you found this video helpful.